Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 2, Lesson 10, Compound Inequalities, and Verse OR. Linear inequalities tend to have an infinite amount of values for the replacement variable that solve the inequality. Sometimes we put two or more inequalities together and ask what x values make up both true and which make either one or the other true. You will deal with and or along with truth values for the remainder of algebra. So let's discuss them in a couple exercises. First, I want to talk about the truth values for and or. A compound and statement will be true only if all the individual statements are true. A compound or statement will be true if at least one of its individual statements are true. Solution sets of equations and inequalities. A value of a variable is in the solution set of an equation or an inequality if it makes it true and is not in the solution if it makes it false. Let's look right away at exercise 4 and put this to work. Exercise 4a, is x equals 2 part of the solution set of x is greater than negative 3? So let's answer that one. Is 2 greater than negative 3? Ask yourself that. And yes, it is. That is a true statement. And is 2 less than 5? That is also true. So therefore, because both are true, this is a true statement. Let's look at B. Is x equals negative 4 part of the solution set of x is less than or equal to negative 4? Well, is negative 4 less than or equal to negative 4? True. Or is x, which is negative 4, greater than 0? Well, that is false. But because this is an or statement, and we do have one that's true, this is also a true statement. Remember, with or statements, all we need is one true. C. Determine if x equals 1 is part of the solution set of these two inequalities. So what that means is I'm going to take that 1 and plug it in. 3 times 1 plus 8 greater than 9. 3 times 1 is 3 plus 8 is 11. Is 11 greater than 9? That is a true statement. And is in between it. Let's do the other side. Negative 2 times 1 plus 10 less than 7. Negative 2 times 1 is negative 2. Negative 2 plus 10 is 8. Is 8 less than 7? No, it is not. So because they are both not true, this is a false statement. Remember, with an and, they both have to be true. And in this case, there's only one that's true. Now let's look at D. I have x equals 5. So I have to plug that in. 2 times 5 minus 1 is less than 3. 2 times 5 is 10. 10 minus 1 is 9. Is 9 less than 3? No, it is not. So that is a false statement. Or, now we have to plug in again. So 5 plus 7 divided by 2 equals 6. Well, 5 plus 7 is 12. 12 divided by 2 is 6. 6 equals 6. So therefore, this is a true statement. Because it's an or, I have one true. This is a true overall statement. Now that we have talked about true and false statements and what makes a statement true and what makes an overall statement false because of dealing with the words and or, we're going to show you in picture form now. So the first exercise, exercise A in number 5, wants you to list the values, and they have to make this statement true. So I have to go from -2 all the way up to 7. So I'm going to start with the values that will make it work. So -2, -1, 0, 1, 2, 3, 4, 5, and 6. Notice here that I included -2, but I did not include 7. And I'm going to show you why momentarily. -2, I'm going to put a dot on -2. What kind of dot on -2? I'm going to put a closed dot on -2. What kind of dot am I going to put on 7? I'm going to put an open dot on 7. And then I'm going to shade in between. This is what an AND statement looks like. Take a good close look at that. So when you see the word AND as a compound inequality, I'm going to refer to it as a dumbbell problem. If you've ever been into a gym, that's what a dumbbell looks like. Picture it. This is the bar in the middle. Here's your bar in the middle, and here are your two weight ends. So you can do your curls with your dumbbell. I want you to see if you can figure out why this is a closed dot and why this is an open dot. And we'll start by talking about that in class tomorrow. Let's go to exercise 5B and talk about the OR statements. First, I would like you to list some values that will make these statements true. So I'm looking for x that is greater than or equal to 5. So for this guy, it's going to be 5, 6, 7, and so on. And on the left side, it's going to be x is less than -1. So numbers that are less than -1 are -2, -3, -4, and so on. So let's plot that now. I'm going to put a closed dot on 5, and I'm going to shade to the right. Notice that my numbers over here, my values, were going up. Then I'm going to put an open dot on -1, and I'm going to shade to the left. A couple hints with doing these. This is an OR statement, and I tell you that it's an OR statement because if I were to draw a guy, stick figure, and let's pretend he's in a little rowboat, and he has his green oars. He's in his rowboat and he's paddling, and those are his oars, and he's rowing a boat down the water. What do you use to row a boat? You use oars to row the boat. So that's how I know that this is an OR statement. The little guy can sit right in between there with his rowboat and use his oars to paddle. Now, a little hint on how to graph these. Notice that this inequality, as long as my variable is out front, this inequality tells me to shade to the right. My variable is out front, this inequality tells me to shade to the left. And that's what I did in both cases. I just paid attention to my arrows and notice that they shaded in those directions. Please take in what you learned today about AND versus OR and dealing with compound inequalities. We're going to continue to expand on these in the future days, but I want you to make sure that you understand that the AND statements look like a dumbbell and your OR statements allow you to use your oars to paddle your rowboat. Have a good evening. Make sure you write your WSQ and that you take in your notes. We're going to now make moves over to page 21 and take a look at exercise number 1. We're going to do more work with OR statements. First thing we're going to take a look at is x is less than 1. So I put a dot on 1. It's going to be an open dot, and we're going to shade to the left. Remember that that open dot is there because it's not included. Now we're going to put a dot on 4. It's going to be a closed dot. We're going to shade to the right. Remember that closed dot means that it is included, and it's closed because of the equal to bar. Let's look at B real quick. We're going to have another OR statement. So it's X is greater than 7, so I'm going to put an open dot on 7, and we're going to shade to the right. Notice that my dot is right on the number line, and my shading is right on the number line. I'm going to put a dot on -2, and it's going to be an open dot, and we're going to shade to the left. Things to remember and notice that this arrow is pointing to the right, so we shade it to the right. This arrow is pointing to the left, so we shaded to the left. In both cases, the variables were out front. C and D are working with the word and, so therefore, don't forget, it has to look like a dumbbell. So X is greater than -3. So I'm going to put it on -3, I'm going to put an open dot. And X is less than 5. So I'm going to put a dot on 5. And it's going to be an open dot. And we're going to shade in the middle. Remember, that is what an AND symbol looks like. If I were to write that as a single inequality, it's very simple. I'm going to teach you a real quick trick. I'm going to put X right in the middle. Always have less than symbols. Because both dots are open, or because this dot on the right is open, this sign will not have an equal to. This sign is open, or this dot is open, therefore this sign will not. And all we have to do is write it from left to right using what we have, including my number. So -3 is less than X, which is less than 5. Let's do the same thing with D. X is less than or equal to 9, so on 9, I'm going to put a closed dot. And then on 0, I'm going to put a closed dot. I'm going to shade in between. And I know we're definitely shading in between because of the word and. This is what an and statement looks like. And the same thing I'm going to do. I'm going to put my X right in the middle, put my less than symbols down. I notice that this guy is closed and this guy is closed, so they both will have equal to bars. So my answer is 0, less than or equal to X, less than or equal to 9. And that's how I write single inequalities. Exercise number 2, it says rewrite it. Okay, so the first thing I'm going to do is rewrite it as X is greater than or equal to -4 and X is less than 6. One of the things I want you to notice that inequality is eating the X. When I rewrote it over here, that inequality is still eating the X. Now I go ahead and graph it. -4 is going to be a closed dot because it's equal to. On 6, it's going to be an open dot because it's just less than. And I'm going to shade in the middle because I know it's an and statement. B, same thing. X is greater than or equal to -5, and X is less than or equal to 9. Dot on -5, it's going to be closed. Closed dot on 9. Shade in between because it is an and statement. For exercise number 3, for each graph, write a compound inequality. So right away I notice that this guy is an or statement because you can draw in your guy rowing his boat, so write your or word down. Remembering that these are all X values in here, so X is going to be less than -1. My X values on this side, including 5, don't forget, so X is going to be greater than or equal to 5. Now, letter B, this is an and statement because it's a dumbbell, so I know right away, put my X in there, and my less than symbols, both of those dots are open, so it's just going to be less than, no equal to. So -5, -6, -8, less than X, less than 2.